This lesson is on slope-intercept form, and we have a little bit of vocabulary to talk about first. It says that in a non-proportional linear relationship, the graph passes through the point, okay, and so we would use the point 0, comma, b, or the y-intercept. The y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. Okay, so our slope-intercept form is y equals mx plus b. Okay, so let's just remind ourselves a little bit of some of our terminology. This is our slope. It's also called the rate of change. This is our y-intercept. It's also called our initial value. For our variables, this would be our independent variable, and this would be our dependent variable. All right, in example 1, it's just asking us to state the slope and the y-intercept of the graph of the following equations. Okay, so if we look here, we know that we're following that y equals mx plus b form. Okay, we're just looking for our slope is our m, which is that number that is attached to the x, so that would be 2/3. And then our y-intercept, don't forget to include the sign. That's just our b, which is in this case -4. Go ahead and pause the video, and I want you to go through and do B, C, and D. Okay, so letter B, y equals -5x plus 3. Okay, our slope is going to be -5, or you could put -5 over 1, and then our y-intercept would be 3. For letter C, our slope is 1/4. Our y-intercept is -6. And then notice that on letter D, there is no number in front of the x, just a negative sign, so that would be a -1, or we could write a -1 over 1 with a y-intercept of 5. All right, example 2 says to write an equation of the line in slope-intercept form with a slope of -3 and a y-intercept of -4. Okay, so here they've identified our slope for us, and here they've identified our y-intercept. So this is our m, and this is our b. All right, so m is -3, and b is -4. So that would be our equation of the line. All right, example 3 is asking us to write an equation of the line in slope-intercept form from the graph that we have shown. Okay, so we're looking for our m, and we're looking for our b. Now, I always say we begin with b. Okay, b is our y-intercept, so we're looking at the y-axis. Where is that crossing? And as you can see, it's crossing at 4. So I'm going to replace this with 4. And then we are going to want to find another point where that goes through the grid really nicely. I see a point down here. And then the easiest thing to do will be to just draw our triangle. So it looks like there's a rise of 2 and a run of 4. The other thing that I want to point out is, remember, when your line is decreasing, we know that our slope is negative. So this would be a decreasing line because it's going downhill. So with a rise of 2 and a run of 4, we know that that slope has to be negative, and we know that that reduces to -1/2. So our equation is y equals m, which is -1/2, x, and then plus 4. All right, let's look at example 4. Why don't you go ahead and see if you can come up with the equation of this line. Go ahead and pause the video. All right, so we're looking at finding m and b. Easiest thing for us to do is to start with b, and it looks like b is crossing the y-axis at -2. And then we're looking to see where else does this cross nicely. Let's see. All right, so I am seeing it go through the grid nicely really at this point 3, 3. So let's go ahead and draw our triangle. Make sure you're counting 1, 2, 3, 4, 5. You're counting the squares. 1, 2, 3. So we have a rise of 5 and a run of 3, and notice that that is increasing. So y equals 5/3 x minus 2. And the last problem on this paper, it says to write an equation of the line in slope-intercept form. We're giving you a slope of 3/4, and we're giving you a y-intercept of -3. So 3/4 x, y-intercept of -3.